everyone, how are we doing? Who do we have live right now? We're gonna do some, I think chapter 13 got some messages about that. There we go. We got the audio going, we got the music going, pulling up the assignments as we speak. Who's in the chat? I don't see anyone in the chat yet. Probably some people in the future watching the video. So we're gonna get the timestamps up. Get the timestamps. People were saying chapter 13. Caitlin, good to see you here. Chapter 13 quiz and a poll taken in December 2012. People ask, so what's going to be our number one way to solve that problem here, Caitlin, as I get it ready? And let's throw Caitlin some points there. What's going to be the number one thing we're going to do? Caitlin, you probably know how we're going to start that problem. How are we going to start that problem here? I was eating some granola, and it's got like flaxseed in it. It's pretty good. It's the kind bars. You know those kind bars? They're really good. And the flaxseed just like... it gets stuck in my teeth. Other than that, I like it. It's very good. But other than that, what is going to be our way of starting that problem? Can we do? Yeah, Savannah, that's what people are asking about right now. Let me know what you're working on. I am getting it ready here as we speak. So what things are we going to do to solve this problem? We have chapter 13 and a poll taken. In a poll taken. Poll taken. I have a poll taken. In a poll taken. Is this the homework, Caitlin? I'm looking at the homework right now. This one said a poll taken. Is it the homework? Oh, it's a quiz question. Thank you, Caitlin, right there. I saw it right in that moment. Caitlin, 100 points. Sorry about that. I looked over and I saw the quiz that you had marked on it. More chill music. That's my chill song right there. My relaxing chill song. Just nice and easy. Okay, here we go. We're getting the quiz questions up. And Savannah, feel free to mention anything. Here we go. In a poll. Ooh. Matt, good to see you here. Nice job, Matt. Knows we're going to get some hundreds here. The poll taken is December 2012. Wrong one. I found a poll taken. I'll go to the screen. We got a poll. Word. Reset the computer. I have the quiz up right now. All the quiz questions. A lot of good multiple choice right there. Good to see you here, Matt. Drop any question in the chat that you're working on. There's so many questions. Of course, gonna be like the last one, right? My word. Good to see you here, Adeline. Here we go. Okay, this is a really good question. I can tell from the start of it. Let me get some Microsoft Word open right here and mark the video. Okay, good. It's opening up all my billion documents that I had open, which I don't need anymore. Don't save. Don't save. Oh my goodness. It's a Monday. Oh, you finished the homework with 100? Nice job, Matt. Let's throw hundreds for that. That's what we like to hear right here. Get those hundreds. It's all about that practice. All about that practice. And right about to start. I could have kept this back. Okay. So let's do this. Organize. We're good to go. Okay. So here we go with the first question of the day. It is in a poll taken. Let me mark the video. 603 Stat 201 Chapter 13 quiz in a poll taken. Okay. So in a poll taken by Gallup in 2012 in December, they asked 1006. Now, what is 1006? Good to see you here, Savannah. Question 3. Yeah. What is 1006? Immediately when you see 1006, what do we always do with questions? So you have to think about with questions right here. What are we always going to do with questions? What are we always going to do with questions? What are we always going to do with questions? What will we always do? It is N, Savannah, or Caitlin, you're right on track right there. Caitlin knows instantaneously that it is N. So this is right here, the sample size. And right here we have, they asked, who were baseball fans? So this is from a poll. So what is this? Yep, Caitlin, you're on the right track. So what is that going to be? They asked, who were the baseball fans? Were you baseball fans? So that is a categorical question that is from a poll. So what is the notation from that? What is the notation from that? So what is the notation from that going to be? They asked who, if you were baseball fans, what is the notation from that going to be? Now be very careful. This is from a sample. So what is this going to be? I think this is a tougher question. That is P hat. And we can call this P hat 1. And this is an older P hat. Or you might call it P hat 2008. And P hat right here, P hat 2012. So that right there is the P hats. And so we have a P hat from 2012. We have a P hat from 2008. And so right there, we have different sorts of sample proportions, which will be used in these problems. And they say a similar sample size. So we could put here that the sample size in 2012 was around 1006. And then the sample size, now it says a similar. So let's just assume it's about the same. And it's going to be 1006 right there. So those are the sample sizes for these problems. And now we go back to the problem right here. It says find the margin of error with 90% confidence. Now for this, we are going to have to use a formula right here. And the formula is going to be P hat plus or minus Z star, and then square root P hat times Q hat over N. Now we need to use the proper P hat associated with whichever one we're doing. So if we're using that P hat, well, they both use the same sample sizes. But what are we missing right here, Caitlin? We're missing something else that we didn't mark in notation. So what else are we missing that was not marked right here that would be great to mark? What else are we missing that would be great to mark? Yes, Matt knows right there, Q hat. So we don't, Q hat is 1 minus P hat. So P hat is equal to 0.476. Now, what is a really good check once you get P hat and Q hat? How can you check your P hat and Q hat to make sure you have the right P hat and Q hat? Like, think about this. You have P hat, you have Q hat. How would you check them? Like, usually you do Q hat with the following, and there's Q hat. So then how could you check your work to make sure you have P hat and Q hat? We always like to do extra checks right here to make sure we have the right values. How are we going to check our values right here to make sure they are correct? Like, you'd be like, wait, did I find P hat? Did I find Q hat? How do we then check our work right here and be like, is this correct? Which is a major thing we always need to be thinking about. To be like, did I do the right work? Are my P hat and Q hat the correct values? And we're using the first poll right here. Just this P hat. There's another poll right here, another sample proportion. Add them together, make sure they add to 1. Perfect job right there, Matt. More points in the chat. That's what we do. If they add to 1, they are complements. And that's the way we know right there. Nat, you are 100% correct right there. Nice job. So now the hardest part for a lot of people is finding what for this equation. Usually a lot of people get stuck on this when they have to find what. Where do a lot of people get stuck solving these problems? And then let's talk about what that concept is. So where do a lot of people get stuck right here? They get stuck finding the z-score. So the z-score has a star on it. Great job, Matt. Excellent work following along. The z-score has a star on it, and this means it's related to the percent confident we are. Now, we need to go over to the apps right here. So the apps are, thank you to Adam Spanbauer once again, who created these amazing apps, which really show how to find z-scores really well. Because what we can do is go to the between button right here and plot 90%. Now, what this shows us is the middle 90% of the curve shaded in. And z-scores are used in the empirical rule for 68, 95, 99.7. And if you'll notice, it's not exactly 1, 2, 3 because we're carrying more decimals. It turns out that the exact z-score for a 95% confidence interval is 1.96. For 90% is 1.64, and when you're less confident, the z-score is lower. These are important concepts to know, that a lower z-score implies less confident. And there's 68 right there. It's 68.26 right there if you really want to do a z-score of 1. But we memorize 68, 95, 99.7 because we don't memorize all the decimals. We just do 68, and that's close enough to 1 standard deviation. A 69 would be 1.02. So 68 is the closer one we use. We don't use the extra decimals. So whenever you're finding a z-score, you need to put in the area between and then get the z-score, which goes from the lower to the upper to tell you how many standard deviations to go out. And I misspoke. This is technically the standard error of the interval right here. Oh, those flax seeds. So we're going to plug in that z-score we found, and the z-score, excuse me. The z-score is 1.645. Just so you can see that again right here. And I usually carry it to 3 decimals. There it is right there. 1.645 is the z-score for a 90% confidence interval. And the reason we're doing 90% is because the question asked us to right here. That is why we put 90% in. There we go. So now what's interesting is it only wants the what of the interval. It only wants the what of the interval matter, Caitlin, or Savannah. It only wants the what of the interval. It only wants the what of the interval, which we don't need to solve the full thing over here. It only wants the what of the interval. And then we should know what that component is. It only wants the what of the interval, the margin of error, which is just that component right there. Nice job, Matt. Me too, man. I've got my caffeine over here. That's the last sip of it. I know what you're talking about. That is some good stuff. 1.476 right there times 0.524. P hat times Q hat over N square root times 1.645. And that is the margin of error. Does it want as a percent? If you don't enter as a percent, just let me know. 3 decimals. So looks not a percent. That's going to round to a 6 right there. Now, what does the margin of error mean? So think about this. If I tell you, we do president's approval rating. Once again, we're not talking political here. But if I tell you the president's approval rating right now is, what is the president's current approval rating? We'll just use accurate data. 40%. So if the president's approval rating is 40% plus or minus 3%, what does that mean? What does it, and I want you to think this over. I want you to think of like the president's approval rating is 40% plus or minus 3%. The 40% obviously came from where? Like, do we know what everyone thinks of the president right now? The president's approval rating is 40% plus or minus 3%. What does that all mean to you? Like, why would we give 40%? And then what does the plus or minus 3% mean? So the 40% is an estimate from a poll. What does the 40% estimate? It estimates the truth for all Americans, because we're polling to see if they approve of the president. And then the plus or minus 3 is the margin of error, because we think maybe the truth is within about 3% of what we estimate the truth to be. Now, we're not saying the truth is in that interval, but we could say we're 90% confident that the president's true approval rating is 40% plus or minus 3%. Now, we could be more confident, which the question gets to in a moment. Great job, Savannah, right there. 100-point margin of error. So the margin of error is giving like maybe the real truth. And good to see your Cassie. Yeah, nice job, Cassie. Maybe the real truth is within the interval. Remember, we just went out and took a sample here. We don't know what the truth is. We're just estimating the truth. We're like, well, my best guess is 40%. We're pretending that's what it was. And it could be within about 3%. So explain what the margin of error means. One is 90% confident, plus or minus margin of error. Oh my gosh, the way they word these sometimes. One is 90% confident that the poll's estimate is within plus or minus of the true proportion. No. This sounds about right here. One is 90% confident that plus or minus, one is 90% plus or minus margin of error confident that the true proportion of adults who are based on, no, is not equal to, is within the interval. This is wrong too. 90% chance, no. In 90% of samples of adults, the proportion who are baseball fans, no. Ooh, this one might be it. There's a 90% chance that the true proportion of adults who are baseball fans is within plus or minus margin of error of this poll's estimate. Yeah. So it mentions that this poll gives an estimate. That's good right here. And that the true proportion is within the margin of error. And 90% probability, I would say, over repeated trials. Don't exactly 100% love the wording, but there's things wrong with these other ones. Like in 90% of sample adults, no, we're talking about 90% confident the truth is in there. So it's not about the samples. This is just a wrong start. One is 90% confident that the poll's estimate. No, we know what the poll's estimate is. We know the poll estimate is this. We're not trying to be confident about what the poll estimate is. That's just wrong right there. One is 90% confident plus or minus the margin of error. This is adding the margin of error to 90% confident. No, we add the margin of error to plus or minus the poll's estimate. And that is literally what we see over here in the formula, that the poll's estimate is p hat. So when it says the poll's estimate, p hat is the estimate because that's the sample proportion. If we wanted to be 99% confident, don't even read their answers. What does the interval do when we become 99% confident? Once again, the answers here might confuse you, but you need to know it conceptually for the test. And we talked about it a moment ago. So when you are 99% confident, what is going to happen to the interval? If you're looking at the z-score, you can understand mathematically what is happening. So there's the new z-score, and if you watch it visually, you can also see it. Here's the 90% confidence interval z-score, and watch the interval. And so here's the 99% confidence interval z-score. And then if we think about it mathematically, and Cassidy has it right there. Great job, Cassidy, working and learning at the same time. So the z-score is going to be 2.5758, and that is going to make it wider. Just mathematically, larger z-score or any sort of level of confidence, which determines the z-score for this interval, it's going to be a wider interval. So now we need to look for an answer that conforms to what we said so that we can get this question right. If we want to be 99% confidence, would the margin of error be larger or smaller? To be more confident, needs to contain the true proportion more often, so it'd be wider. So we're more confident, so it would contain it more often. That's in line right there. Now I think it wants the second poll right here. Find that margin of error. Oh, it just wants you to redo it. Well, does it use that second poll? Am I confused on this? Be careful before turning it in. Did it just give us... Hey, good to see you here, Sarah. Did it give us erroneous information? Is that whole second poll not even used? So Cassie, is that... It looks... I'm not even seeing that second poll being used. Maybe that second poll is just extra info to them for them to confuse you. But I thought there was a... we're just solving this equation now. I'll change this to a 6 over here because I think that's enough decimals and hard to read that writing. So that's the z-score for 99% confidence. We put a star on that to denote relative to confidence. We're only solving what's in the interval right there. We're only solving the blue portion because that's the margin of error. 0.476 times 0.524 square root times 2.576. And there it is. So 4% now. And as we said, it would get wider. So you have to make sure your answer goes along with this. And right here, there's that. In general, if all other aspects of the situation remain the same, will the smaller margin of error produce greater... Okay, let's see right here. It's a weird question. In general, if all other aspects of the situation remain the same, will smaller margin of errors produce greater or less confidence in the interval? Well, if you have a small... And it's now going back to over here. I think it's saying if sample size remains the same. I really don't like how that's worded. To make a smaller margin of error, we would generally have less confidence. 80%. That can't be the one we got wrong, right? Good. Let's find out. It's not this. It's not talking about that second poll, is it? I was a little worried. Did we get a conceptual one wrong? That's right. No. What? One is 90% confident that this poll's estimate... Oh my gosh, how did I read this wrong? One is 90% confident this poll's estimate is within plus or minus... Oh my gosh, what? There's a 90% chance. Yeah, I don't know how I misread this. Did I read this one? Sorry about that, right there. So yeah, it should... That probably is acceptable right there. How did I get this one wrong? I usually say, I am 90% confident that the true proportion is contained in the interval blank to blank. I think the chance they got mad at. It's over repeated trials. I should have noticed. I don't know why I misread this one. I think my brain's still waking up from the coffee. So it was a conceptual one. Sorry about that, Caitlin. Did you get 100 on this one? Make sure to change this answer right here. I want to go back and look at the tape and see what I said right there. It's one thing I want to point out is on the test, you will need to interpret these intervals. So hopefully people are still watching this right here, because you won't be clicking buttons on the test. You will be saying things like, if we made that 99% confidence roll, I am blank percent confident that the blank is contained in the interval blank to blank. So with this, I am 99% confident that the true proportion of adults who are baseball fans is contained in the interval. And then we had 4% margin of error. So it would go down to 43.6% to 51.6% right there. And this is how it would be on the test. And we're able to find this interval and interpret it. And this is what you would be required to write out when you solve the interval down here, which would give you the mathematics of 0.476 plus or minus 0.04. Does that make sense, Caitlin? Like this right here, and this right here is what you're going to be tested over. I always try to make it very clear what the test is going to look like so that you know while solving these problems, this is what you should focus on. If you're not able to write this sentence up here from these intervals, that's where you'll lose points on the test, because there's about 4 points. At least with this one, I think there's a 4-point question. It'll be similar in terms of what you're finding, but you'll have to say something like, I am this percent confident that the this is contained in the interval this to this. And we can do a lot of different work with this. We'll do a crazy morning this morning. But here we go. Let's look at one last thing right here. Yes. So Caitlin, think about this. This is how quickly we can do the work when we're doing work in statistics. If you go out and talk to, let's say, 50 people around campus, and 20 of them own a pet, then you are trying to estimate what? So you talk to 50 people, and 20 of them own a pet. What are you trying to find out right there? So you talk to 50 people, and 20 of them own a pet. What are you trying to find out? $50 people and 20 of them own a pet. What are you trying to find out? $50 people and 20 of them own a pet. What are we trying to find out? We're trying to estimate what? Well, what would we be trying to find out right there? So we say, do you own a pet? And we're trying to find out what right there. So if you look at the notation, 50 is the sample size. X is the number of successes right there. So what are we trying to find out? We are trying to find out the true proportion of people who own a pet, right? Because we have here a sample estimate, and our estimate is 40%. 20 over 50 is 40%. So that is technically P hat. It says the sample estimate of P, which is the truth. So we don't know P. We're estimating P right there. So that's the way this program is marking the notation, is to say this is a sample estimate of the true proportion. So we would say right here, I am 95% confident that the true proportion of people who own a pet is contained in the interval 26.7% to 54.7% or 54.8%. And so that's how we usually do statistics without having to do a fill in the blank question, where we just put in the numbers and then we understand the interval right there is trying to estimate the true proportion of students who own a pet. Does that make sense, Caitlin? Like this right here, if you understand what this interval means, that's what we're trying to teach by doing all these multiple choice questions. So it's better to be able to see an interval like this and be like, okay, Brian went out and talked to 50 students, 20 of them owned a pet. He estimates that 40% of students own a pet, plus or minus about 13, 14%. This one's not a symmetric interval, but you can kind of see the margin of error if you subtract from here and take the upper minus the center. Whoops, did an extra decimal. It's about 14-ish%, but it's also not symmetric due to the chi-squared distribution. Different topics for different days. Let's do Savannah was wondering about, and we don't have any other questions after this, but Savannah was wondering question 3 on the homework. Oh, and then the quiz or something after that. Let's see. So we only have one more question. What do we have? One more question. Drop those questions in the chat. What questions do people have? What questions do people have? We only have one more question. Let's go look at the questions. Question 3 on the homework. So here we go. Chapter 13, editor, you got it. Okay. And Statue 1, Chapter 13, homework. This is question 3. Okay, very important questions right here. We have in a morning consult poll, they asked people, do you think America's on the right track or the wrong track? And it says calculate the margin of error for the proportion of U.S. adults who think America's on the wrong track. So what do we immediately have to do with these problems? Yeah, I'll be sending it out. They're finishing grading. Good question, Cassie, right there. I'll be sending out the form here soon. They should finish grading in the next couple of days. I'm going to check in on the graders to see how they're doing, and we'll make sure that they've graded, and we'll be sending out a form for any questions you have about exam 2. Thank you, Cassie, for asking that. So, Savannah, what should we do immediately with this question? Or Caitlin, what should we do immediately with this question? These are the steps we want to practice and know. I'm going to write something down below here while we do this. Now, I wouldn't write this to start, but I kind of know where this question is going. It's actually 4. Okay, we'll do 4 next. You got it. We'll do 4 after this. So what should we do for this question, Savannah? What should we... No worries, Savannah. We'll do this question, then we'll do question number 4, since we started this one. What should we immediately do with this question right here? What should we do? What do we need to do? Yeah, let's just practice it right here. What's the first step we do when we're doing this question right here? What's the first step? What do we do? What are our steps to make sure we get the question correct? Got to practice our steps. First thing we do is what? We get a question like this right here. We're going to what with it? These are the steps. So when you get to the test, you're like, I know what to do. I'm going to what my what to start. Leo?
Notation, brother.
What are we going to do to start? The first thing we're going to do is what? Write the notation. We're going to write some notation right here. Yep. Now we're trying to estimate, what does it want? It wants the margin of error of the interval, so it doesn't matter which way we put it in. Now the hard part for people a lot of times is the z-score. Remember, it usually has a star. Put a star up here. Star means it's related to the percent confident we are, so we need to see they want, I think, a 90%. And we looked that up a moment ago. You'll need to go over to the apps. Good to see you here, Jesse. Working on some confidence intervals. So you'll need to go over here to the apps screen and get the 90% confidence. Make sure to click the between. You have to have between clicked and see that you have 90% graphed between z-scores of negative 1.645 and positive 1.645. So that's going to be the z-score right there. You need to go to the apps to get that. We would give it to you on a test. I've also got a lot of them memorized. Now, we're only thinking about the margin of error right here, so we don't have to worry about the remaining portion. So we do not have to solve the rest of it. Over 19. It's weird. It looks like a date right there. And 0.753 times 0.247. Those are complements. Square root times 1.645 right there. And now we go back. There we go. And we've done it. There's the margin of error. Explain what the margin of error means. And once again, they're just doing interpretations right here. Please remember that we prefer to do interpretations ourselves, where we say things like, I am blank percent confident that the true portion of adults who are baseball fans is contained in the interval, and then we give the interval right here. So you need to know how to write this. And if you just say it or write it, that's good. But please say or write these out. So what I would say is, and we did get the margin of error. Let me go back to it. I am. We have 1.6 right here. And so let's write our interval. If we're using that right there. And that's going to be move the decimal. And so basically, I am 90% confident the true proportion of adults who think the country's on the wrong track is contained in the interval 73.7% to 76.9%. So we go right there. So 1 is 90% confident that there we go. It says observed. 1 is 90% confident that the observed proportion of adults that responded wrong track. Don't like that. Really don't love their interpretations. The probability that any given adult surveyed, no. 1 is, okay. Okay, so this is interesting. They always want to kind of help you think about what these things mean. I am 90% confident that the true proportion of adults that think the country is on the wrong track is within, and then we have to put the margin of error right here of the sample proportion, which is the estimate. So you might say is within of the population proportion, but that's the truth. Our estimate is what we think is true. And I wish they just said right here the true proportion. That would make a little more sense. Should be really. I do not love their wording. Probably on the wrong track is no. So let me I do not like. I'm going to talk to my Pearson about this. Let me read over that question again. My brain could still be booting up. Let me read over it. 1 is 95% confident that the observed proportion of adults that responded wrong track is within. Is not usually how we talk about it. The observed is for the sample. This really, I might even tell Terry we should remove this. This is right here really not, because the margin of error is used to estimate the truth, and observed is from a sample. And usually we say that the truth is expected to be within this much of the sample, but they're kind of reversing it that the observed, do not like that. It's been a crazy morning. All right, let's take a look right here. So now with this right here, a poll conducted. So Savannah, what are we going to do first? What is our first step right here? What do we do first, Jesse? What is our first step right here? Oh, we need to mark the question. What is our first step? Notation, exactly. So what notation do we have? What notation do we have? Close. It won't be P, though. Be careful. It won't be P. Cassie, you're on the right track. But remember, this comes from a sample. Cassie, you're on the right track. So those come from samples, though. So very clearly and carefully, and this is why I think I'm so mad at my Pearson, because sometimes I think the people who write the questions sometimes is P hat. You have to be very, very particular, because we're going to be solving P hat plus or minus Z star square root P hat times Q hat over N. And so this right here is P hat. And so then Q hat is 1 minus P hat, which is going to be 0.479. And we just do 1 minus to get that. So 1 minus P hat equals Q hat right there, and just plug in P hat for the equation. Now, the Z star is usually where people get stuck. Where do we have to go to find this Z star right here? Where do we go to find that Z star? Where is Z star going to be found? Help me out right here. Remind me where Z star is going to be found as I mark all my notation right here so we can see where things go with a little more color coding. It's going to be found where? It's related to level of confidence. So the star means relative to confidence. When we do a new formula here today, we will not use level of confidence. The new formula today will be P hat minus P naught over P naught times Q naught over N square root equals Z, no star. So, and great job, Jesse's already there on the apps. This is a different formula. It has no star on the Z. That does not mean relative to confidence. So the star right there is very particular for relative to confidence. So we go over to the apps page that Jesse's just listed there for 100 points. And now we bring it up to 95% confidence and use 3 decimals for 1.96. The Z is how many standard errors we're going out for the relative confidence right here. and it's 95% confidence. So now we plug in 1.96 and we do square root. We plug in our numbers 0.479 times, well, that's Q hat. And we plug in right here. And then we plug in 4527. There we go. So now that we've got our numbers in the equation, we first solve for the margin of error. And we divide by 245. There we go. Margin of error is about 1.5%. I'm going to round it to that, plus or minus. There we go. And let's see what the problem wants. It does want it as decimals, so 1.5%, it says to round to 1 decimal. So it's 47.9 plus 1.5. There it is right there, top number. And 47 point... Oh, no, it's 52.1. How in the world... Oh, my gosh. Whoa. I am just doing random things today. And then we change that to a decimal. There we go. Okay. Now we solve. Make sure to mark your notation. 52.1 plus or minus margin of error. And the margin of error was 1.5, right? Yes. Okay. And so that's going to be the upper. Now we can subtract 1.5, and that's the lower. There we go. And now that we've got the interval, good work right there. Now, once again, so I want to pause right here. We did this one, much longer version during office hours last week. Should you read their interpretations? Very important question right here for Jesse, Cassidy, and Savannah. Should you read their interpretations and try to answer the question this way? If you're working this question right now, I want you to realize this. Should you read their interpretations and just try to figure out which of these is correct? Not really, though. Here's my 100 points right there. Not really. What is the best way to do these questions? Not really, right? Don't read their interpretations. Because on the test, you will have to what? On the test, you will have to what? They're not great, right? You have to write your own. Write your own first. Okay, so think about what we're trying to analyze here. We're trying to analyze what? We're trying to understand the what. So there's a hint right there. What are we trying to understand? What are we trying to understand? Great job, Sarah, right there. Write your own, exactly. So make this a 500-point question. I want someone to practice this. We're going to, as soon as someone gets it, we're going to give out those 500 points. So we're going to do a whole step procedure right here to realize how to write the I am blank % confident that the true blank is contained in the interval blank to blank. So we're going to practice doing that. Then we're going to look at our interpretations here and see which one it is. Hey, Emma, good to see you here. So this is what you should practice before looking at any of these right here. Don't look at these answers because they're, they might go for some. We're trying to understand the proportion of respondents. So Cassie has, we are trying to understand the proportion of respondents who answered, well, not just that they answered, the true proportion for all Californians, right? So it's not just from this poll, it'd be for all Californians. Does that make sense, Cassidy? We know from this poll, 52.1% said they're going to move out of state. We want to know for like all Californians, like we did a poll to see if people want to move out of state. So what's the true proportion of people for all of California who want to move out of state? Perfect answers, Cassidy. We're just gonna throw you 500 points right there. So, and then we'll do another 500. So we're just throwing crazy points here. This is the big practice. So what's the interpretation? There's the interval right there. So here is the saying. So I want you to write the interpretation. This is where the practice makes perfect or makes better. I want you to write your interpretation. So I need you to write the interpretation now. So this is just an example interpretation, but we have the skeleton right there to put stuff into. This is the part where usually people make mistakes. The % confidence pretty easy. The interval's pretty easy. The part, and usually I say that the true right here. I like to say true right there. Because we always say true something. We are 95 for this one. Maybe your interval's different. Oh, be careful right here. Oh, you might be looking at this up here. Not this one. Go over here to this one. Cassie, great work. We're gonna throw one more 100 points. Do this one over to the left, Cassie. Great work. Use this one right here. And I think you basically have it. Yeah, Cassie, that is, you literally have it. I'll give you the 500. You just have to, I think all you have to do is copy paste what you wrote, switch the confidence, switch the interval right there, and you've got the answer. Does that make sense? I am. You can say we are. I like to say I am. The notes say we are. Either one's fine. I am. You see, they say one is, which is the same as I am, basically. So we've pretty much narrowed it down to one of these two choices right here. Just looking at our format, I am 90% confident. 95. Boop. That the true proportion of people who plan to move out of state is contained in the interval blank to blank, and we just plug in those numbers. So not too bad when you learn to do it. One is 95% confident from chapter 13. Yeah, we can do that one here. We got one more for that, Emma, but you got it. That the true proportion between, that sounds right. One is that probably, no, it's not about a random individual. It's about the true proportions. And you see right there, that is what we're trying to estimate. So we were talking bad about the interpretations before, but what's really funny is this is an excellent interpretation. This literally follows our exact format. There we go. We got it right. I am. And then it says, what in the world? Oh, they're asking if 50%. So since high cost of housing has been a cited reason for why people remain out of state, they're going to invest in affordable housing if they can be sure that more than 50% plan to move out of state. Number 10? Yeah, we got a lot more time. So do we think... Oh, no worries, Emma. We'll get it done here, and we'll check it out later. Thank you, Emma, for being here. So do you think that more than 50% of Californians plan to move out of state, and why? Do you think that more than 50% of Californians plan to move out of state? Because you're 95% confident the true proportion is somewhere between 50.6 to 53.6. So do you think that more than 50% plan to move out of state? Cassie, I think you're on the right track. We would say, since the interval is entirely above 50%, so you see how the interval's above? So we think, I think I get what you're saying. More than 50% is all above the interval. So there's good evidence, I would say, that more than 50% want to move out of state, because we think it's somewhere between 50.6 to 53.6. Cassie, great job right there. This would mean they should invest, because they're going to invest if more than 50%. So since the interval is entirely above 50%, we do have evidence to do that right there, and good stuff right there. Yep, we're 95% confident the truth is there. You got it. And excellent work. We got a few more questions right here, and great job, Cassidy. Excellent job following along right here. I think, did someone have editors? Kaylin has editors preparing a report. Okay, let me put that here, and then we have chapter 10. I'm going to mark the questions. Editors preparing a report from the quiz, and then question 10 on the homework. And then Emma was wondering about we have editors preparing a report. Okay, cool. Good question here. Let's go back over here and do the editors preparing a report. Here we go. Editors preparing a report. And chapter 13 quiz. Might be a sample size question. Those are interesting. Yeah, it is. Okay. Editors preparing a report. I remember this one. It is a sample size question. 543. Stat 201. Chapter 13 quiz. Okay. Let's go check it out. So how in the world would we solve a question like this? So what's the first thing you think we're going to do if we got a question like this on the test, which we rarely put stuff like this on the test? We have put questions like this. I'm not the biggest fan of them because it's basically a math question. What do you think we're going to do for a question like this? I mean, it's good for certain practice right here. But so you're going to see the answer to how to solve this. This question will be very easy in a moment. But what a great question. Well, it's good. It's good for a reason. And the reason it's good is what?
Notation, brother.
What is the reason it's good? Because it's going to help us know how to do what? It'll be very easy in a moment. It'll be super easy. Like once we know a certain thing, we can solve this question in like 15 seconds, 20 seconds. What is this question going to be good for? The key to solving this question is going to be what? What do we need to solve this question? We really need some what? How are we going to solve it? No one knows how to solve it yet. Leo gave us a hint. What is going to be the key to solving this? So we need to always remember our steps. And whenever we're solving a question, it's usually going to boil down to what? A lot of these questions for the remainder of the semester, label the notation. Caitlin right there. Great job. So let's go here. And now this is the hardest problem because, yeah, we can do that one too, Matt. Yep. What we have right here is the following equation. And this one is tricky. I actually had an instructor ask me how to solve this years ago. Okay. So notice we are missing something very important right here. We've marked multiple things. And frankly, it asks about the margin of error right here. Margin of error is everything after the plus or minus. So that's the margin of error. And that is equal to 3%. Does that make sense? Everything I've written out right here, does this make sense so far? The margin of error is everything after the plus or minus, and we don't have p hat. So we don't have p hat, and if we don't have p hat, we don't have q hat. Now, if I had to ask you, and we're trying to find n, right? So we are solving for n, but can you solve an equation when three things are missing? Could we solve an equation when three things are missing? We'll talk about z here in a moment. But can we really solve an equation for a certain value when three things are missing? We really can't, right? If I asked you, and this is kind of, don't worry too much about this. If I said, what proportion of UT students do you think blank? What would you guess? So now I didn't tell you what proportion I'm asking for, but if I said, what proportion of UT students do you think blank? What would be your guess of the true proportion? Or what do you think we would see in a sample? If I said, what proportion of UT students blank and what proportion don't blank? It's a weird question, but you're like, what are you even asking about? I'm just asking you a random proportion. You think what proportion would be most likely? Now, you don't know what it is. You're just saying, well, I'd probably guess around what if I have no idea what you're even talking about. So think if you had no idea what we're even talking about, what would be a good guess? And that's why these numbers will be used right here. You don't even know what we're talking about. We're just saying what proportion are blank. What would be a good guess? Probably your safest guess would be what of the proportion that blank? Because that is the hardest part of this problem. If we don't know, 50% is our best guess. What that actually does is it actually makes the interval as wide as possible. So 50% is the largest numbers you can put for p hat and q hat, which actually create the widest margin of error. So if anything, we're estimating the margin of error to be larger. And if the margin of error is going to be a larger p hat, q hat, it will require a larger n for a certain related margin of error right here. So this actually is the safest p hat and q hat to use when estimating. So there's a lot of theory behind why you'd use 50%. You'd ensure that you had a margin of error of less than 3%, 3% or less, no matter what your p hat and q hat are, because these are the largest values for p hat and q hat that lead to the largest margin of error, which means we would have to have a smaller sample size. So once again, the theory behind all this is not super important for especially Stat 201, but that is why those values are used right there if we did not know what the values were from a sample. So with this in mind right here, now it comes into solving for n. We now have all the values listed, but where are we going to get this 99% confidence? And take a moment and see if you can solve what the value is here for the z star. So take a moment. Who can solve the z star value? This is a very important step that I think a lot of people don't know how to do. What is the value of z star? Where do you have to go for the z star, and what is its value? See if you can solve it right there. What is the value of z star? I'll show it here in a second, but if you're following along and practicing, these are the keys to understand if you have a 99% confidence roll and you're using a Z interval, you need to go and find it. 2.5758. Caitlin got it right there. So we need to go to the apps page right here. Great job, Caitlin, right there. Good practice, worth 100 points. And we're going to go right here to the between and go and type in 99. There it is right there. And Caitlin did the extra decimal worth another extra 100 points for 2.5758. And that's how we got the value right there for the Z star. Now, what I like to do is I don't like to solve it right now. I like to solve it as though we can solve for any sort of problem by doing the following. We're going to take right here and multiply. We're going to put this back to ME over here. That is the margin of error. We're just writing the notation right here. So margin of error is that 3%. And then we're going to go right here and divide both sides by Z. And now we're going to square both sides. And that leaves over here P hat, Q hat over N. And so we're just doing a little algebra. And now we're going to flip both sides. So you can actually flip things, which will put N up top right here and put P hat, Q hat on the bottom. If you flip one side, you have to flip the other, mathematically speaking. And that's still the square of this. And now we're just going to take and multiply both sides by P hat, Q hat. This is all the algebra right here. I did it in a few compound steps. But does that make sense right here? And now we're left with this nice, neat equation on the bottom. How does that look and make sense there? Caitlin, I think this was your question. This is the algebra right here. And now we're just going to plug in the values of 2.5758 over margin of error 3% times 0.5 times 0.5 right there. So yeah, that's the easy way. Yeah, I know. We've had like one question like this on the test. We've done like one question on the test like this. So I put slow on the mouse. Like my mouse feels slow. So there's the mathematics in there with the Z-score of 2.5758, the margin of error of 0.03. Oh, we didn't square it. And then we multiply by 0.5, 0.5, because those are P hat, Q hat. And that's how you solve it. And so then we're just going to solve this out right here. And 2.5758 divided by 0.03, square this quantity. That is the quantity square, right? Because it was square rooted. Double checking, times by that. And there it is right there. I think it says round up right now. So let's make sure we did it correctly. Round to the up. Do not forget to round up. It will count off points. Actually, I think lately they've made it so it has a little bit of a margin of error. I think they changed it. Yep, they did. They used to be really mean about this question. So if we do a different version of it, you can see right there is 601. We can confirm the answer right here now that we know the equation. 95% confidence is 1.96. Divide by 4% margin of error. Square this value times by this right here. And there's the value right there of 601 rounded up. Does that make sense how we can easily get this question right here? 90% confidence is 1.645 divided by margin of error of 0.01. Square that value times by 0.025. And there's the value. Ooh, I think I did a wrong number. So be very careful. If you type something in incorrectly, you will get the wrong answer. And I said 0. There we go. Question on the homework? Yeah, I'll take a look at it right there. Just showing that once we know the equation, it just becomes plug and chug right here into a problem, which is not the goal to just plug in numbers and be like, oh, Z-score for this is 1.645 divided by margin of error of this. Square the value, get this, times by that. That's where I made the mistake. And there's the value right there of 1.88 or 188. So once again, understand the notation. If you know the notation for this, it really becomes plug into an equation and solve. But just to review again, we went through here and marked everything we had for this and understood what it was asking. If you're wondering why this is the margin of error, 100% on the quiz. Caitlin, great job right there. I didn't even get 100. We got through Caitlin 500 points. We're talking about those big points this morning. Brian even made some errors right there. Caitlin, I think you're paying more attention than I am because Caitlin got that 100 on the quiz right there, and that's what we like to hear. So great job. It really boils down a lot to that notation and understanding what it's asking. You're welcome, Caitlin. I'm very proud of you right there. That's amazing news. Thank you so much. I really mean it that just hearing things like that really makes my day. I love hearing that people are doing well. Please tell me if you're not doing well in the course. But when people are like, yeah, I just aced that quiz, I'm like, woo, we did it. Yeah. And then when I make an error, I'm like, oh my gosh, how did I not read that question properly? How did I do that? How did I read it too quickly? It happens. It happens. You know, you'll make mistakes. I'll make mistakes. But then we go for those hundreds, you know, and then we're like done with it, and then we just need to practice and review it when it comes time for the test, just to refresh our memory. Because remember, it's not about solving one question, it's about understanding how to solve the questions. So we got a question 10 right here. W for everyone right there. Abu, good to see you. Thank you, Abigail, too. W's for Caitlin in the chat right there. I'll throw a W in the chat. Mubot, quote 9 is F in the chat from Mubot. But we need a W in the chat. Mubot needs some W's for people. F in the chat, Mubot. How dare you? Okay, I think we got some, some good, is question 10, right, Savannah? Question 10 on the homework? Yeah, got that marked next. And then I don't know if we have any more questions. Okay, so let me, we are at the 57:23 mark. Stat 201, chapter 13 homework. Let's go take a look at it. Here we go. A consumer advocacy group published a study of labeling of seafood in 3 U.S. states. The study found that 13 of the 23. So what are we going to do immediately here? What do we do here? They found that 13 of the 23. What do? We start hearing things like that. We're thinking what?
Notation, brother.
What are we thinking? 13 of the 23. Don't even read their questions yet. 13 of the 23. Don't even read their questions yet. Don't even read their questions. Notation. Savannah knows right there. Nice job, Savannah. We're not even going to read what they write yet. Okay, so let's go take a look. What's the notation? I think a lot of people get stuck on this because we overthink it. Like if I said, let's say 12 out of 20 people own a dog. Very similar to numbers right there. What is the notation right now currently? Or 13 out of 23 people own a dog. A lot of people get stuck on these notations because we don't use it so often. What is the notation? Just take a shot at it. If you're wrong, doesn't matter. Savannah, Savannah, nice work. So what are we finding right there? What did you find, Savannah? Close and good answers. Not quite P, though. P would mean you found the true proportion. So if you said you found P, you found the truth. So you didn't find P, you got an estimate of P, so you found what instead? 100 points, keep it up, Savannah. You didn't find P, you found what? You didn't find the true proportion of seafood that's mislabeled. You actually found what? P hat, which is the estimate. So what is the formula for P hat? Just type that in quickly right there. P hat, which you did find, is 13 over 23. And the formula for that is what? And great job, Savannah, right there. So what are those things up there? Like just 13 is what? 23 is what? You're doing a great job right here. Good practice of notation. X over N. Yep. Number of successes over number of trials. So that's the sample proportion. Boom. Just, the more you use it, you're like, oh, well, 13 of the 23, that's the amount of the successes over the number of trials. So we already know the sample proportion. You know what? We're already going to get right here this. What value am I calculating in my head very quickly? Size, exactly, amount of successes over sample size. X is successes, like things we see conforming to something, and then N is sample size. So how many things out of the total population meet this criteria, the proportion that are that criteria. And we have right here, this is equal to Q hat, which is the complement of the sample proportion, which is 1 minus P hat. So there we go, and just make sure those add up to 1, and you're good to go. Let's see what they're asking about this. Okay, are the conditions met? We have right here exactly 13 successes and exactly 10 failures. Did they say they took a random sample? They did, so random is passed. I would assume that 23 is less than 10% of all the salmon that exist in the world, or red snappers. And then we have at least 10 successes, at least 10 failures. So I think this is the one right here. So know your conditions. Yes, because it's a random sample, the sample size is less than 10% of the population, and there are at least 10 successes, at least 10 failures. There's exactly, how did I figure out there's 10 failures right here? So be very careful. This is a good thing to know. How many successes exactly were there and how many failures? So you could do NP hat needs to be greater than or equal to 10, and NQ hat needs to be greater than or equal to 10. Now there's a quick solve. What is NP hat actually equal to? So we could plug in P hat and Q hat, but what is NP hat actually equal to? I'm kind of hinting at it right there. Mathematically, NP hat is equal to what? because NP hat is the proportion of your sample that is successes. So it's from your sample size, what proportion were successes. It's equal to X. So NP hat is mathematically what? NP hat is mathematically what? Like, what is the numeric value of it? Like 5, 8, 13, 12? What is the numeric value of NP hat? NP hat is... What is it mathematically? It's not 1. So we can plug in the values to check. We could go here and go 23 times 0.563. So what is that going to equal to? And these are good theory things to understand right here, Savannah. So we don't want to just say we passed the conditions. We want to know that we want at least 10 successes, at least 10 failures. Yeah, which one? And then, Matt, I think you might say it again here, Matt, and I'll mark it in the notes for us to do next. So what is this value equal to? It's not 1 point. Good guesses, Savannah, right there. Not 1.29. You might have moved a decimal. You might have moved a decimal on this. So it won't be 1.29. Check your math again. You might have moved a decimal. So double check your work, and then remember the theory. A city ballot? Yep. It's about the parking garage, maybe? I think there's one about a parking garage. Not quite 12. It'll actually be if we carried every decimal, which this is not every decimal carried. If we carried every decimal, it would be 13. You might say, well, that's not 13. Well, 13 divided by 23 is this, times by 23 is 13. So right here, NP hat is equal to, say it with me, say the one letter it's equal to again, NP hat is equal to what? No. This is the practice, Savannah. Savannah, keep it up. This is the practice. I really appreciate it. We're here to practice and get better at these things. 500 points. Keep up that great work. So what is NQ hat going to be equal to? NQ hat is the proportion that does not conform, or the amount, I should say. Q hat is the proportion, and then NQ hat is the amount of the proportion in the sample that does not conform. So if 13 conform and are mislabeled, how many would not be mislabeled out of the 23? So how many out of the 23 would not be mislabeled? So if 13 are mislabeled out of the 23, and you can solve the math over here, but you can also get the answer conceptually speaking right here. 10. And does that make sense? So we know how many are mislabeled and how many are not mislabeled. So here's the thing. What do you notice about these numbers? Both are greater than or equal to 10, and that's why we said there's at least 10 successes, at least 10 failures. And I think that's where people usually do these questions too quickly and make an error. So what we have to do now is all we have to do is plug in the what for a 90% confidence interval. All we're going to have to do now is what? All we have to do now is what? Plug in the notation. You got it. Well, what's the z-score? So, Savannah, I want you to do this one right here. Find me the z-score for a 90% confidence roll. So take them all right here. Go to this web page and find me the z-score for a 90% confidence interval. What is the z-score for 90% confident? So go to that web page right there. I'll give you a few seconds right here to check it out. Practice on it to know, since we're doing relative to 90% confidence, what is the z-score? What is the z-score? So we want to go to the web page. Close, Savannah, close. Make sure you've clicked the between. I think you're clicked below right now. So I think you've clicked below. So this wouldn't be a confidence interval right here. Technically, it's a left-tailed confidence interval. We don't usually use those. We usually use the middle symmetric intervals. So keep going right there. 100 points right there, Savannah. Change it to between, though. change it to between, and then it'll look like a usual confidence interval. So once you click between right there, what do you get when you click between? And then we usually carry to 3 decimals, which I've got to 4 right now. You can carry to 3 or 4. 4 is a little safer. You can carry to 10 decimals if you want. That's going to be more than enough. But click the between, and what do you get then? So once you click between, the z-score for a 90% confidence interval will be what? We'll always use between for confidence intervals because it goes from like a lower to an upper. So between, click between right there, and you should have the answer. 1.645. Yep. So one, and it rounds, if you go right here to round to this. Oh, it says 1.64. 1.645 because it's 1.6449 technically. So I usually do like 3 decimals or 4. Safest to do 4. Great job, Jesse and Savannah right there. Great practice. And we have to know how to get those z-scores. Those are usually the hardest part for people, where they get stuck. Say, how do I get that z-score? And once we get the z-score, we should be pretty good. Now, remember, we're talking about the percent of red snappers that are mislabeled. So I want you to think what we're trying to estimate. We took a sample of seafood for red snappers, and in our sample, we saw 56%, 56.3% that are mislabeled. So we are trying to estimate the what? We are trying to estimate the what? We are trying to estimate the what right here. What are we trying to estimate? Because they might have us interpret the interval, which I would do after this. We are trying to estimate what? And Matt, we got your question coming up here next. What are we trying to estimate as I solve the math? That's the margin of error. 56%. Oh, yeah, it's a very small sample size. .03. Something like that. Plus or minus 17%. What are we trying to estimate? And let's see, does it want... Oh, it doesn't want as a... So we want to use this as decimals right here. Okay, so 56.3% plus the margin of error, 73.3. Whee! 73, 0.733. What are we trying to estimate? Does anyone know? There's that, and there's minus. So all we're doing is doing plus or minus the margin of error. So the decimals. What are we trying to estimate, though? What are we trying to estimate? Does anyone know? It's going to have us interpret that next, I think. And this is the lower bound of the interval. That should be good. What? See, to 3 decimals, 90. My error was... How did I even see that? Wrong confidence level. So we need to change the z-score to 1.96, classic number right there. It's going to change the margin of error. What are we trying to estimate, though? And so 0.563. I'm just seeing if people catch these errors. There we go, square root, and then times 1.96. There's that, 20.2%, 20.3 rounded up. So there we go. And this should be easy enough to do the mathematics with. Yeah, it's so easy, right? What I'll show you something here in a second, Jesse. Like, so that's right there, right? 176.6. Look at that again. There it is. And 36. What's really nice is when we usually do this. I think this is right here. No, is it? There we go. There you go. There's 90% confidence. There's 80% confidence. There's 99% confidence. That's usually how we do the work right here, Jesse. Like if I'm going to do work and make confidence intervals. Now this doesn't use the same exact interval, but you could get an estimate from this because this uses the chi-squared. See how this is 34.9% to 76.1%. It's using a different calculation because different statisticians have come up with different ways to calculate this with different assumptions, and the chi-squared is a totally different distribution. But this right here is an interval with 95% confidence, and I could switch it back to a 90% by just doing that right there. And you notice it is a tighter interval. Okay, and now we go to our interpretation. And this is where I like to focus your attention, because when you think about this, with your interval, you will have to write this out on the test. So I am, and then the confidence part is easy. The easiest parts of this are the confidence level and contained in the interval blank to blank. But what are we trying to estimate right here? We are trying to estimate the what. And this is where the hardest part for people is this second thing right here. What are we trying to estimate? The blank blank that are what? And they tell it to you up here at the start. The context, which we need to know for every problem, is up here at the start. If you look right here, we are trying to estimate the what. The true what of the whats that are what. And that's the context we need. Not sold that are, you're on the right track, Jesse. You're on the right track. So it's not that red snappers kind of red snappers that are sold that are what? You're on the right track. Because I think, and then the answer down here will say it. Like, I am 95% confident. Oh, they say right here, there it is, right there. The true proportion of red snapper packages that were a different kind of fish, like mislabeled. Does that make sense? That were mislabeled. And so we know what was tested. We want to know for like all red snappers. So imagine we go to, does anyone here like, I can't think of the name of the store. What is it called? The place, Trader Joe's. That's what I was thinking of. Let's say you go to Trader Joe's and you want to get some mahi-mahi fish. And so you've got some way to test mahi-mahi fish because you're big on that fish. You love that fish. So you go and you say, well, I want to make sure it really is mahi-mahi fish. So then you test 23 packages from your Trader Joe's, and 13% of the 23 were mislabeled, like they weren't actually mahi-mahi. So then you're trying to estimate the true proportion of all the Trader Joe fish, the mahi-mahi fish, because you're only looking for that type of fish, not all fish, because you can't extrapolate to all fish. You only tested a certain type of fish. So you're trying to estimate the true proportion of mahi-mahi fish that are mislabeled. And think about this. Is it possible at least half of the mahi-mahi fish are mislabeled? From your estimate, is it possible that at least half of the mahi-mahi fish are mislabeled? Like for all Trader Joe's. Sorry, Trader Joe's. Go check out Trader Joe's. Good stuff right there. Is it possible that like half of them are mislabeled? I mean, you don't know what the truth is. Well, would you think it's possible that half are mislabeled? Yeah, because it's in the interval. Because you think the true proportion that are mislabeled is somewhere between this and this. Now you have your estimate, and your estimate of the amount that is mislabeled is 56.3% from what you took. Your sample had 13 out of 23 mislabeled, so you estimate the mislabeled proportion to be 56.3%, but then you're like, but I could be off by about that amount right there. The truth could be somewhere contained in an interval with this margin of error from my estimate of the truth. So always kind of think about what we're doing. Like we would go down to our Trader Joe's, we'd get 23 samples of mahi-mahi. We'd find out that 13 are mislabeled. So we'd estimate the true proportion that are mislabeled is 56.3%. But then we'd be like, well, but I have this amount of uncertainty in my estimate. And that's the margin of error right there to say, well, maybe the truth is somewhere contained in the interval 36% to 76.6%. Once again, you have to understand what you're doing right here. Like, why are we doing this? We're trying to understand what might be the true proportion mislabeled. So know how to write this out. I am 95% confident that the true proportion of red snapper packages that were mislabeled as some kind of other fish is contained in the interval 36% to 76.6%. Okay. Not the ones purchased for this study, because we know that. That is the sample proportion. And so now we go here. Not going to make any more errors. We say that, we're going to make an error. Boom. Got it. Okay. I'm confused on this topic. If you go from 90 to 95, 80%. Yeah. So think about this. And so that's Matt, you said it basically, and Matt, I think you got the next question. An 80% confidence interval is water. An 80% confidence interval is water. You can see it right here visually. It's water. It's tighter. Smaller and tighter. We would say tighter, right? So you would probably have the truth in there less, right? Does that make sense conceptually? Like imagine if I told you, like who's your favorite sports player and what sport do they play? I might be able to tell if you said someone like LeBron James, I'd know basketball. So like give me your favorite sports player and the sport they play. Yeah, when you see it visually, and I think this might help too. Like, who's your favorite sports player and a sport they play? Who's your favorite sports player? And then we'll do your next question right here. Because I think sometimes the conceptual things can be the hardest part. But then when we talk about it with context, Brady. Okay, so think about this. Brady is going to score a certain amount or get a certain amount of touchdowns over a season, right? So like there's like 15, 16 games in a football season. Brady gets like 2-ish touchdowns a game, maybe. So if you were to estimate with only like 80% confidence the number of touchdown passes Brady would throw in a season, maybe you'd estimate somewhere between, you'd say, I am 80% confident. Here, we'll write it out. And then we're going to do the next question right here. I am 80% confident the true amount of touchdowns Brady will get this season is contained in the interval. And this is just kind of theoretical talk, like 28 through, or we'll do it even easier, 30 through 40. Okay. So when you look at this interval right here, if we were to go to 99% confidence, we would make the interval even wider. We'd say something like 20 to 50. I'm trying to think if it is still at the same center. It is. So don't worry about the mathematics too much for this. But when Brady has a season, there will be a truth, right? Before the season, we don't know what the truth is. So we're making the interval to estimate what the truth might be. And the truth is more likely to be contained in the confidence interval that is larger. So as you wrote right here, if you go from 95 to 80, so if we were to go down from here, if we put 95 right here, then we'd have a tighter interval, and the interval will contain the true proportion less often. So this will contain the truth for whatever Brady's season is less often. If we were to make 80% confidence intervals to estimate something about a player, it would contain the truth less often than a 95% confidence interval, because after the season, there will be a truth. Does that make sense? 95% confidence interval means over repeated trials of making these intervals, 95% of 95% confidence intervals will contain the truth. So the 95% confidence interval will contain the truth more often than an 80% confidence interval. Does that make more sense right there? Yeah, City Ballot, you got it. And so this is a big conceptual thing right here. And we love doing conceptual stuff here. Let's do the City Ballot. Here we go here. It's on the quiz, right? Let's do that City Ballot question. I am blank percent confident that the true blank is contained in the interval blank to blank. Let's check it out. City Ballot question. Oh, found it. Oh, it's got a bunch of confidence stuff on it. Let's do it. Gambling? Okay, City Ballot question. Step 201, Chapter 13 quiz. A City Ballot. Okay, a city ballot about a local initiative would like to legalize gambling. Hey, it's your money, do with what you want. The issue is a hotly contested issue, and two groups decide to conduct polls to predict the outcomes. The local newspaper finds that 48% of their 3,200 randomly selected voters plan to vote yes, while a college statistics class finds that 47% of 600 randomly selected voters are going to support it. Both groups will create 95% confidence intervals. Assume that all voters know how they intend to vote. So it's just removing bias right there. And then it requires a majority vote. So we're looking to see if they get at least what percent. Like this is just saying no bias, that they're not going to change their vote. And then this right here says we want to see if there's at least what percent vote from these polls. So we want to see if there's at least what percent from these polls, which will be probably going towards the end. What are we looking for? The initiatives require a majority. What are we looking for? What does majority mean? At least 50%. Great job, Jesse, right there. So if you look, there's similarities in what we're doing in the notation right here. The only similarity between both of these polls is that they're both going to create what's from these. The only similarity between both of these polls is that they're going to create what's from these. Someone noticed why I paused on that. First poll. Second poll. They are both creating what? Putting hints in the notation right here. They are both creating what? They are both creating what? They're both doing 95% confidence rolls. So they're both going to have the same level of confidence. Now we pause here. I want someone to go find the Z-score for 95% confidence. This is a skill you should have. You don't have to memorize these. It's going to be basically two. They're both doing confidence rolls and both 95% confidence. That's why I didn't mark it as 1 and 2 for like sample size 1, sample size 2, proportion 1, proportion 2, 1.96. Classic right there, Jesse, 100 points. And we have to go over to the apps right here. We love putting it in the chat right here. MuBot's going to tell you where to go, and you go over here and type in 95. Make sure to do between because that's a confidence roll. And now we have the Z-score 1.96 for 95% confidence. So with this, they're going to have us calculate the margin of errors right here, I believe. No, they're having us calculate the full interval. So we're going to literally have to go in here, and here's p hat for the first. Is that that's the second poll? Oh, that's the thing right there. That's that. What is Q hat for the first poll? What is Q hat for the first poll? Be very careful. Use the... oh, I did it. No. Let me be really nice. Cool, because these are the same. We don't have another yellow. There we go. Now we got all the notation marked. What is Q hat for the first poll? For the first poll, what is Q hat? What is Q hat for the first poll? Those flax seeds. Had some granola this morning. So what is Q hat? Great job, Jesse, right there. Yep. Make sure these add up to 1. And the first poll had a sample size of 3,200. Second poll is 0.47. Once again, trace back to the color coding I've done up there. Same Z-score, 1.96. Square root, 0.47. The other number is going to add up to 100 right here because it's Q hat. And then over the smaller sample size. Now, smaller sample size means water margin of error. When the sample size, and this is theory you should know, when the sample size is smaller, the margin of error will be water. So the second poll has a smaller sample size, so mathematically the margin of error must be water. And you can also think about this theoretically, that if you had a smaller sample, you would be more or less uncertain. So there's a good way of understanding it theoretically too, that if you have a smaller sample, you will be what? More or less uncertain, which margin of error is your amount of uncertainty, like a plus or minus is your uncertainty. So a smaller sample size would lead to a water margin of error. Very important right here. A smaller sample size will lead to a water margin of error. We can confirm this down here mathematically in a moment. A smaller sample size, all other things the same, which there's theory questions on this too, will lead to a water margin of error. And we'll see this mathematically. Good theory question right there. Smaller sample size, all other things the same, which we technically don't have, but it's big enough of difference. Larger margin of error, because with a smaller sample, you'd have more uncertainty. So we'll go ahead and solve these intervals. And yeah, Jesse, yep. Smaller sample size, larger margin of error. Yep, that is correct on the theory. And so 17.3. And that's the first interval right here. And the second interval is going to be go. And that's, well, it's basically 4%. So let's put it to that. Oh man, that's a much, did I do everything correctly? Because that's a much larger margin of error. I guess that kind of makes sense. Looks correct-ish. Always want to check your work. Yeah, it's 4%. So there we go. There's the math right there. And now we go back. Without finding the confidence intervals, explain which one will have the larger margin of error. It will be the statistics class will have a larger margin of error because it has a much smaller sample size. It has a much smaller sample size. Just the theory right there. Hey, good to see you right here. Oh, my audio is kind of low. Double check yours. I might have been actually moved away from the mic. Am I better now? Thank you very much, Sarah Didi. Yeah, I might have been moved away a little bit. I think I was leaning towards the screen. I was like, my bad vision. Thank you so much. 100 points right there. Might be better when I'm closer like this right here. So thank you so much. Now we have the intervals. Let's do our intervals right here. The intervals are going to be, ooh, this is an interesting interval. And plus, oh, no, I forgot a 0 on this. I'm gonna double check. That should be right there. Yeah, thank you so much. I think I forgot a 0 because that just doesn't mathematically make sense. What? What am I doing? I need help doing math. Okay, we gotta double check that. What did I do, everyone? I'm not doing my math correctly, Jesse. Like, I am 0.48 times 0.52 divided by 3200 square root times 1.96. So it was the first number. What am I doing on my math, right? So now we got to double check it. I think that's right there, Jesse. We'll go out on a limb. I think the other number should be 46.3, right? So 46.3. Usually they give you a little bit of a leeway. Oh, they're doing right here. So here's the margin of error. So let's go here and times it by 100. There we go. That's the easiest way right there to do it. And then we have 48% plus that. So 49.7. And then 48% minus, and there it is right there, 46.3. So double check your work. Easy to make errors. Now remember, they're putting percents right here, so we don't want to put decimals. That's probably where a lot of mistakes can happen right there. So those do have percents right there. So make sure they're put in as percents, not decimals. The statistics class right here is going to have the lower interval, and this rounded to like 4% on the dot. Let's go ahead and resolve that margin of error just to double check. 47 times this divided by 600 square root times 1.96. Now let's turn it to a percent. Jesse, great job right there. And then we're going to take 47% plus, where'd it go? Over there. We don't want that. So we'll put it around here. And 47% plus this. There's the 51% that Jesse mentioned. And Jesse's correct that we're going to take and subtract. And there's 47 minus the margin of error. 47, really? 47 minus the margin of error right there, 43%. Okay. Which group concludes that the outcome is too close to call? So think about this. The newspaper, which did a larger sample, thinks that somewhere between 56.3% to 49.7% will vote in favor of gambling. The statistics class thinks that 43 to 51% will vote for gambling. So which group thinks it's too close to call? Because they're both thinking the truth is somewhere contained in this interval. The statistics class, because they took a smaller sample. Now, here's the thing. Both are only 95% confident. So it could be, and it does contain 50%. That's why it's too close to call, exactly. But here's the thing. They could be wrong up here, right? They're only 95% confident the truth is in there. So sometimes, and this is why people don't get it, is sometimes it's not that the polls are wrong, but, and I do want to point this out, the way Nate Silver does his intervals, huge fan of Nate Silver. Let's go to election night 2016, 538. So here's his forecast. And when Nate Silver, I'll show you here in a moment, when Nate Silver's making his forecast, where does he show it? Electoral vote. Here we go. Nate Silver, he should, yep, there it is. Nate Silver is only what % confident in his polls? Nate Silver's only making what % confidence rolls here? Nate Silver's only making what % confidence rolls for the amount of electoral votes that the person would get in 2016? That's what a lot of people don't understand, and you should always know. He's only making 80% confidence intervals. So he's only 80% confident the truth will be in there, and he even says it. 80% chance of falling within the range. The truth is what he's talking about. Now, here's the thing. Do you see the interval for Trump, which goes down to here and which goes up to here? Now, what you'll notice is that Trump, if we go here, and let's go find this out. Oh my gosh, we hit the random button. 2016 election electoral votes. So if you take a look, Trump got, he got 304 electoral votes. Trump got 304 electoral votes, and if you look, his interval goes right up to 304 because Hillary's up there at 302. So you know what's interesting? Nate Silver's 80% confidence interval looks to contain the truth. So 304 is what Trump got, and it was at the upper edge of what Nate thought was possible with that interval towards the end. And a lot of these intervals for Trump right here, 304, contain the truth. So someone might be like, well, he said Trump would get 235, but his margin of error is like plus or minus 70 electoral votes. So there's a pretty big margin of error in there. Like Trump, we are 95% or 80% confident, so it's not even a 95, which we usually use. We are 80% confident that Trump will get between somewhere between 305. Yeah, exactly. So when people say the polls got it wrong, I'm like, did you look at the margin of error, which is the amount of uncertainty in the poll? Yes, the poll made a prediction which is wrong, but we have to take into account the margin of error to say I am 80% confident the true amount of electoral votes that Trump will get is contained in the interval like 150 to 310 electoral votes. And you know what's funny? The truth was in that interval, but it was at the upper end, which it can be because we don't know what the truth is. And sometimes an 80% confidence will get it wrong. Good question. Well, this is Nate's. So very interesting. Good question right there. This is actually not a poll. The way Nate Silver does his work is with simulations. And what's really cool is in the later versions of these, 2022, that's what current, House elections, 538. So we would say in a certain amount of simulations, we see something right here. So this is his more recent sites right here, and they do it via simulations, and they show like, no idea what's down there. Sorry, random, what in the world? We saw like the cowboy, New York cowboy guy. Oh, it was just a random ad. Thank you, random advertisement. The PC down there. Now it's something about like, we're watching an ad for who knows what down here. I think it's Progressive or something. Make the most of your MLB games. I don't even watch sports. Yeah, random ads down there. Top stories, Nate Silver. What you advertising? There you go. Oh, we're not even looking at it more. Use ad block, right? I should. But it's really cool if you go down to different states and stuff. You can see by random ads up there. He's got, oh, look, there's the confidence intervals. So there it is right there. And he does it via simulations. So huge fan of Nate Silver and his work. We can go buy some purses and stuff. But really cool to look at how this is all done and his simulations. There it is. The deluxe version of our model simulates the election 40,000 times to see who wins most. The samples out of, simulations. Yep. So he's doing like Monte Carlo simulations and stuff. So he's not exactly polling people, but I think they base the simulation on polls. So maybe look at Real Clear Politics maybe. But that is how he's doing his work from what I understand, the more recent stuff right here. And then you can see like all the random simulations right there. So pretty neat. Like he's got all these nice infographics right here. And from what I know, he's been up and there we go. Which polls influence? There you go. So then he's got the polls down here showing like how they're getting their data. And I mean, when you look at this data right here, it's pointing in that direction. But then how accurate are the polls? Because that's the big question is like if there's bias in the polls, then that's going to lead to bias right here. Hey, Kat, good to see you here. Maybe do a question or two more right here. But these are the kind of big questions right here we like to ask. I think I have a meeting. Let me see right here. 2 seconds. I think that's the end of office hours. Let me see. I think it is time. Yep, it is time. We'll be back here tomorrow. Bye for now, everyone. Bye.